Hello, I'm glad to present you my scientific work dedicated to the digital model creation for the hydrocarbons production and special processes of preparing for transportation obtaining with help of special mathematical procedures and of course maple sources and uh, interesting tools implementation. And I would like to say that Markov processes, chain, and apparatus will be the guide for the well state identifying and at all the oil and gas production process improve and development. So let's start. And first of all, I want to point out the main steps for the digital transformation of technological operations. Generally speaking, the industrial data processing tools need to be implemented in the the uh, at all process of the hydrocarbons production realization uh, because the oil and gas layers are sophisticated and multi-component systems which are open, non-stable, dissipative, uh, and have the high degree of uncertainty, which we have to reduce from time to time, from step to step. So that's why we need to apply the special mathematical procedures as well as correctly organized visualization and analytical apparatus. Um, uh, and these opportunities can be the base for the correct decisions making in the branch of hydrocarbon production process paces rise and effectiveness, productivity, and so that rhythmicality of main operations improvement and just stability supporting. Um, as well, we need to understand that measurements which can be obtained from special apparatus, from smart sensors, for example. The parameters can be just well bottom hole pressure, oil and gas flow rate, the speed of the bearing, the pump pressure, and another main parameters. These parameters essentially and obviously contain the special noise component, which we should to just point out, and we should take into account the special mathematical procedures which can be the um, first essential tools for the initial uncertainty degree reducing of the whole hydrocarbon production management model, digital model. And we should not forget that the time period which we choose as the uh, special direction in future planning, have also the influence, and we should take into account that the correct well state and behavior with the main parameters and identification can be the great support and just can be the little guidelines for the future organizing integrated processes formalization. That's why we need to estimate well productivity from phase to phase. And let's look on the slide. We can see the three parts of the digital model, which was developed especially for the main procedures of oil and gas production parameters rise, increasing, improvement, and rational methods for the oil and gas processes identification, realization. So we see the first part have the structural character, organizing and systematical behavior, and these part help us to build the correct structure of the model of the special subsystem, for example, for the main parameters identification and evaluation. As well, we should estimate the industrial object state on every stage of production, and we should take into account the correct and so that true planning or operation organization. So which tools we can choose? I offer you the combining approach, which you can see from the circled parts. The first is hydrodynamic model creation. The second is the correct mathematical tool formalization for the well state evaluation. And reliability, quality, confidentiality, just correctness, parameters identification, as well as risk evaluation organization. And this approach can create us the true digital analytical application for well state conditions control. And you can see that you can be sure I wouldn't forget to say about Maple, wonderful tools for the mathematical procedures realization. First of all, let's see on the left figure. You can see the digital reservoir model, stochastic model, and the Maple platform was the base for the creation of this type of model. You can see on the second figure the Maple visualization tool application for well observation. You can see the just analytical approach and a special process of the signal interpretation, for example, from analog type to digital type. And you can see the process of the reservoir model uncertainty reduction, we should know that making decisions support platform can lead us to the quality, reliability, and effectiveness rise. And this part, of course, just have two destinations. Firstly, is actuality, correctness, and interpretation of well measurements. The second, of course, risk management in order to reduce the potential probability for unplanned and dangerous situation on the oil and gas production industry. So it is very important and it's an essential destination and branch of research for the oil and gas world management industry. So let's look on the analytical tool parts. Firstly, is technological characteristic of the industrial object. For example, well, potential states and consistent probability values, and we should know active operation time. For example, the count of the run of pumps, as well as, for example, coefficient of exploitation of the pump, and, for example, it is the period of just correct and stable work with the best characteristics. And with the information actuality estimation, we can obtain the qualitative and rhythmical model. What about key criteria components for digital production? Of course, these management stages and mechanism identification. We can see the planning perspective solution, of course, and the model calibration and timely updating, and the timescale simulation, of course. And I want to give you just the look on well-productive parameters information model formalization. In my opinion, the industrial processes correct description and investigation can lead to well-productivity parameters informational model creation through the evaluation of object technical characteristics and environmental conditions, of course, because environmental behavior is unpredictable from time to time, and we know that the environment has the high degree of uncertainty, and sometimes we should take into account several ways of the behavior of this factor, and that's why we should use the probability indexes reduction of the possible dangerous situation and risk minimization. On the screen, you can see the reservoir surfaces formation, of course, with the mathematical and visualization tools, and you can see the stochastical behavior of the reservoir surfaces. I want to present you the special approach which can based on the cube of the information, digital cubes. You can see, for example, that gas flow rate depends on temperature, and the third What about Markov processes tools application? You can see that from which from each state of a well, we can just gather the important and necessary information. For example, you have a look on the graph from the right part of the screen. You can see the figure with the graph states graph. S is the state of the well. Lambda is the intensity coefficient, and of course you can see the edges between the vertices of the graph. These are the possible transformation from one state to another state, and on the left side you can see the possible states of the well. And you can see the Kolmogorov-Chapman equation system. The first. Secondly, we can process this system just with special conditions. And if the intensities are known, the system from the point 2 will be transferred to the point 3. And you can see this system of equation. And finally, we have the result which can be presented as system state probabilities in each mode type. And for example, just with a probability of approximately 20%, have the second well. So we can see this well stage average counter relation. We can choose the system average states count estimation, which can be named as M, and this value is depend on numerical parameter of each part of the industrial subsystem, and of course, secondly, this parameter M depends on the probability which we had already evaluated on the previous stages, on the previous slides. And if n is equal to the 10, then we can obtain the next values, which you can see on the screen. So the equation system 1 for the non-stable mode will transfer to the system 4. And if the initial probability for the first state is equal to 1 and another equal to 0, so we have the solution which you can see on the right side of the slide. These are the final distribution of probability, final probability estimation, and you can see the array of potential well states and the percent of the time, the part of the time for each well state, and these result can be obtained with the Maple soft procedures. In conclusion, I want to say that Maple tools can be the interesting and correct decision for the well state estimation, for the correct calibration of the hydrocarbon production dynamic model, which you can see on the screen, and just for the rise of hydrocarbon production paces, as well as ecological, economical, and technological resources just support stable state just of the processes investigation and rational approach realization, we should integrate the information from different sources, and of course turn to the um, uh, just mathematical apparatus tools and special operators. And from these great sources and with help of these sources, I had the opportunity to create my scientific work. Thank you for attention, and I would be happy to listen to your questions. Thank you.